All right, guys, today we're going to look at lesson 5.1, transform graphs of functions. All right, so transformations that affect the range of a function. Okay, remember the range is your y values. All right, so it says, given the graph of a function f and a non-zero constant k, you can create a new function g by adding k to f of x or by multiplying f of x by k. In both cases, g and f pair the same domain values to different range values. The graph of g is the transformation of the graph of f. All right, when you transform something, you change it in some way. In mathematics, a transformation is a change in the position, size, or shape of a figure or graph. All right, so that's a big definition there. Make sure that you take a minute, pause the video, and get that. All right, then it says the graph of S is a semicircle shown in blue. Okay, so we can see the f function here in blue. Note that the semicircle is circled at the, or centered at the origin, has endpoints at -2, 0, and 2, 0, and passes through the point 0, 2. So you got -2, 0, we've got 2, 0, and it passes through the point 0, 2. The mapping diagram shows g of x equals f of x plus 2, and the graph of g of it is in red. All right, so it gives us the domain. Here's the domain of f, and here's the range of f. So if you see -2, 0, -2, 0, 0, 2, and 2 zeros. So those are your ordered pairs that create this semicircle. All right, so if we add 2 to the range of f, 0 plus 2 is 2, 2 plus 2 is 4, and 0 plus 2 is 2. So the range of g in red is going to be these numbers here. So we're going to have the same domain, just a different range. So we're going to have -2, 2. Here's -2, 2, 0, 4, and 2, 2. All right, so now it says choose the number and word to best complete the statement. The graph of S is translated 2 units up to obtain the graph of g. So this function is just shifted 2 units up. Okay, and that's what it looks like. G of x equals f of x plus 2. So we just shifted the whole graph up 2 units. All right, now it says choose the number and word to best complete the statement. Now let g of x equal f of x minus 2. Okay, so now we're looking at a different function. G of x is going to equal f of x minus 2. The graph of x is translated 2 units down. Minus 2 means it goes 2 units down to obtain the new function of g. All right, that's all for this example. We're going to move on to task 2. All right, task 2, transformations that affect the range of a function. All right, remember the range is your y values. We're still looking at changing the y's. So it says the graph of f is a semicircle shown in task 1. The mapping diagram shows g of x equals 2 times f of x, and the graph of g is red. All right, so this one has your domain -2, 0, 2, 0, 2, 0. So the blue function f is the same as in task 1 as it says. Now we're going to multiply instead of add. So we're going to multiply f by 2. So 2 times f of x, and 0 times 2 is 0, 2 times 2 is 4, and 0 times 2 is 0. So our new range is right here. And so the red, or the g function, has this domain and this range. So -2, 0, 0, 4 is my middle ordered pair. And then 2, 0 is this one. So you can see this time it has kind of been stretched. All right. So the graph of f is stretched up by a factor of 2. So when we add or subtract it, we move it up or down 2 units. But this is by a factor of 2 because we multiplied it by 2. All right, it says now let g of x equals -2 f of x. The graph of x is stretched by a factor of 2, and then the negative sign makes it reflect over the x-axis. So that's how you get g of x. So the 2 stretches it, and the negative sign flips it over the x, or reflects it over the x. All right, so now it says, finally, let g of x equal 1/2 f of x. The graph of f is compressed to obtain the graph of g. Each point on the graph of g is half as high above the x-axis as its corresponding point. All right, and again, you can graph these if you want to make a table. To look at those bottom 2 examples, you can do the exact same thing. You can put -2 in here and see what the range is, and then see how it graphs it, and it'll flip it upside down. And then if you want to multiply by 1/2, you can do the same thing and see how it compresses it instead of stretches it. So that's all for task 2. We are going to look at task 3. All right, this is lesson 5.1, task 3, transformations that affect the domain of a function. All right, the domain, remember, is your x values. So when you create a new function g by adding a non-zero constant k to x in f of x, or by multiplying x in f of x by k, g pairs different domain values than f does to the same range values. The graph of g is a transformation of the graph of f. The graph of f is the same semicircle shown in task 1. So we're starting with the same semicircle we started in task 1 with. The mapping diagram shows g of x equals f of x plus 2, and the graph of g is in red. All right, now in the mapping diagram, note in the mapping diagram, you have to work backwards from the domain of f to obtain the domain of g. All right, so now we're looking at f of x plus 2. So this time we're affecting the domain instead of the range. Okay, so in blue is the same semicircle we've had in the other 2 tasks. So these are our ordered pairs for the domain and range of f. And then you can see instead of affecting the range now, we're going to affect the domain. Okay, so we took some number, added 2, and got this domain here. So -4 plus 2 is -2. -2 plus 2 is 0, and 0 plus 2 is 2. All right, so you can see on the graph, you can see that these points are your original domain and range, and the whole thing has shifted to the left. Okay, so when it's x plus 2, it's going to shift it to the left. All right, so choose the number and words to best complete the statement. The graph of f translated 2 units left to obtain the graph of g. All right, now let g equals x minus 2. Okay, so it's probably going to go the other direction. So the graph of f is translated 2 units. This time it's going to go right to obtain the graph of the new function. All right, so the easiest way that I remember this is when we're looking at the range. The range moves it up or down, the same as the sign. So when we added 2, we moved it up, which is what we expect. When we subtract 2, we move it down, which is what we expect. With the domain, it's kind of doing the opposite. So when you have x plus 2, you kind of expect it to go to the right because this is where the positive x's go. But it doesn't. It goes opposite. So it's going to go left, and same with this one. This one's going to go opposite what you expect, just because you're working with the domain instead of the range. So that's kind of how I remember it. If it's a vertical movement on the range, it moves same as the sign. If it's a horizontal movement on the domain, it moves kind of opposite the way you expect it to. All right, that's all for task 3. All right, task 4, transformations that affect the domain of a function. Again, domain is your x values. The graph of f is the same semicircle shown in task 1, 2, and 3. The mapping diagram shows g of x equals f times, or f of 2 of x, and the graph of g is in red. Note that in the mapping diagram, you have to work backwards from the domain of f to obtain the domain of g. All right, so here's the domain of f, the same domain we've had, and here's the same range, the same semicircle we've had in the other task. All right, now we're going to multiply the domain by 2. So these numbers here are multiplied by 2, and that gives us our new domain for g. So g is negative 1, 0, 0, 2, and 1, 0. So let's look at what that does to the graph. Okay? All right, so it says the graph of f is compressed. See how it's like squeezed in towards the y-axis? Compressed horizontally, because we're looking at the x's, the domain now, to obtain the graph of g. All right, so it says the x values change while the y values stay the same, so the change is horizontal. The intercepts both move inward by a factor of 1/2, so it is compressed. So you can see that even though it's multiplied by 2, it is moved in by a factor of 1/2. Okay? All right, so now it says let g of x equal f of negative 2x. How is the graph of f transformed to obtain the graph of g? Choose the correct word or phrase to complete the sentence. All right, so now we're going to have f of negative 2x. So the graph of f is compressed horizontally by a factor of 1/2. Remember, it's doing the opposite. It's compressing it 1/2, and the negative sign reflects it across the y-axis. All right, so it would flip it upside down, and it's going to compress it horizontally. All right, now it says choose the word to best complete this statement. Finally, let g of x equal f of 1/2 x. The graph of f is stretched. Even though this number gets smaller, it's going to stretch it horizontally to obtain the function of g of x. And again, for each one of these, if you want to see that visually, it has the explanations here underneath it, but you can make a table of values pretty easily and look at the shape of that just like they did above. So it kind of helps to visually see what this is doing to each function. All right, that's all for task 4. If you have any questions, let me know.